Okay, 8.5 is where this really gets tough. So you're going to need to pay attention. I will try and go slow, and hopefully we'll be able to get there in the end. So in order really for a function to be invertible, it has to be something that's called 1 to 1. And that means that the definition of 1 to 1 is exactly one input for every output. So if I have a function like f of x equals x cubed, that looks like this. And remember, input is the x-axis. And the output is the y-axis. So I have an x value, say 2. 2 cubed corresponds with only one y value. Okay? If I have 10, x is 2, y is actually 8. But there's only one. So if x is 10, okay, then y is actually 1,000. 10 cubed is 1,000. Okay, but different though. So this f of x is 1 to 1. But if we look at another function, x squared, that function looks like this. Okay, that is x squared, where we have one input, 2. Okay, and then another input, -2. And we have the same y values for both of those inputs. So we have 2 inputs with only one output. So this function is not 1 to 1. And the reason why we care, we talked about this example earlier, where we have this is x squared, and if we took the inverse of this, technically we would have plus or minus the square root of x, which looks like this. And if you remember back to middle school, the vertical line test, where I have a vertical line that touches this function in 2 different places. So it is not a function. So the inverse of x squared is actually this. So it's not a function. So what happens actually when you take the square root of something, your calculator does something called a domain restriction for you, where it cuts off the left side of the function. So where x squared, the domain, is -infinity to infinity, the domain of x squared is -infinity to infinity, so we have to cut off the left half, so we make the domain restriction from 0 to infinity. I cut off the left half. I do this. I cut off the left side. So then when I take the inverse, I have a new domain of 0 to infinity. 0 to infinity. It looks like this now. And when I flip it along this line, it would look like that, which would be y equals the square root of x. So that's why we need to do a domain restriction for every function that is not one-to-one. And there's a really easy test to see if a function is one-to-one. We go back up here. It's called the horizontal line test. Horizontal line test, where I could draw a horizontal line, and just like with the vertical line test we did here, it touches in two different places. So this function is not one-to-one. So your strategy is to graph with the calculator. Let's do example 2 in your notes. So we are going to graph this. Let's see if we can zoom in a little bit. To graph it, you do math num abs, and you'll have that. So we do 3x. We want to graph it though. So math num abs, and we do 3x squared. No, not 3x squared. 3x plus 2 minus 7. When you graph that, and zoom 6, and we still have stuff from before. So we need to do second stat plot and turn that off. Like that. Okay, and you can look at it and see I can draw a horizontal line anywhere on that graph, and it will be touching at two different spots. So this does not pass. Does not pass the horizontal line test. Fails the horizontal line test, so we need to do a domain restriction. So to do the domain restriction, we need to find that point. Okay, so we do second calc, and it's a minimum. Go to the left of it, hit enter, go to the right of it, enter, enter, and the minimum is negative 0.66 repeated, and then the y value is negative 6.99. So we're going to call that 7. So negative 6 repeated, and then 7. Okay, so we need to cut off this left side, the left leg of this graph. So the domain initially of this function is negative infinity to infinity, but we need to cut off to this point. The x value of that point is negative 0.67. So I'm going to go negative 0.67 to infinity is my new domain. That's the domain restricted. Okay, and then the range is 7 to infinity. And that's important because that is the domain. When I swap x and y, I also swap the domain and range. So this is the domain. This domain of the original function will become the range of the new inverse function, and the range will become the domain of the inverse function. I hope I said that right. So when we swap x and y, we also swap the domain and range. So the domain of inverse is the range of the original function, which is 7 to infinity. You'll see when we do this. The range of the inverse is the restricted domain of the original function, negative 0.67 to infinity. Okay, zoom out a little bit. Okay, so our function, now we're ready to swap x and y. Y equals the absolute value of 3x plus 2 minus 7. Swap x and y, so then x equals the absolute value of 3y plus 2 minus 7. And that is just awful. Add 7 to both sides. X plus 7 equals the absolute value of 3y plus 2. And then to solve for that, we need to do plus or minus that. So we're not going to worry about that, actually. I'm worried it's going to get too muddy for you solving absolute value functions. The way to do that, actually, you do 3y plus 2 equals x plus 7, and 3y plus 2 equals negative x plus 7. And you have two different functions, but we're not going to do that. We're going to mess you guys up. Let's do this one. Let's do example 3. F of x equals 9 minus x squared. So again, we're going to graph this. 9 minus x squared. We're going to graph it, and it looks like that. Okay, I'm hoping that's not a surprise to you. We need to find the vertex. If you think about transformations, change this around a little bit, you should be able to find that is negative x squared plus 9. That's up 9. There's no left or right. There's no c. So I hope you can see that the vertex would be x is 0 and y is 9. X is 0, y is 9, and so we need to cut off this left leg of this. So the domain originally is negative infinity to infinity. I need to cut off the left leg, so it's the x value, the domain restricted, would be 0 to infinity. And it's a square bracket. So all I did was I scratched this. So the vertex will give me the very highest point y value and the x value that goes with that. So that's how I know it's from 0 to infinity. It's always the x value of the vertex. So that is the domain restricted. And then the range is from negative infinity to 9. It's the highest it goes. Okay, and that matters because this becomes the domain restricted of the original function, because it becomes the range of the inverted function. And then the range becomes the domain of the inverted function. So let's do that. Y equals 9 minus x squared. X equals 9 minus y squared. We need to solve for y. So I'm going to minus 9 over x minus 9 equals negative y squared. And divide by negative 1 to cancel that. So then it would be negative x plus 9 equals y squared. Then I square root both sides. So y equals negative the square root of negative x plus 9. And the domain of the inverse is the range of the original function, negative infinity to 9. And the range of the inverse is the restricted domain, 0 to infinity. And if you think about this function and what it looks like with the transformations, this looks like it would be actually right 9, because it's c over b, which would be negative 9, right 9, right 9, and then it has an x-axis reflection, so it goes from like that. So negative infinity to 9, and from 0 to infinity. And then it's actually kind of cool, x squared plus 9, that looks like this. 8, 9, and that would look like this. And always the intersection of the two functions will land on y equals x. Which actually would be right here also where that intersects. I hope that's making sense to you guys. I get that it's a lot and it's confusing. I'm going to avoid number 5 absolute value function again, because I think that will be confusing, and there's none like that on your homework, so we don't have to worry about it. So f of x, number 4.